Hey, welcome to Radical Academy. My name is Mike Wada and I am the founder of Radical Academy. So, welcome also to the second party of our topic that I started, I think should be some 2 days ago. So, this is a continuation and we are calling it part 2. Now, this video, or rather this part, is about the magnitude, which just simply means the size of something, or rather the size of a vector. Now, if you're watching this video minus watching the video introductory part to vectors, I encourage you to go back and watch the video so that when you come back to this video, now you'll be able to understand and just get the key concept and fundamentals in the vectors. Okay, so now without wasting much of our time in this video, now we'll be looking at vectors, magnitude of the vector. So we saw some of the vector notation, some of the vector representation, that a vector can be presented using capital letters, where we put the arrow on top of the the two ends of the line. And then we also saw how we can represent, or in terms of representation of the vector, we saw that the vector can also be represented using a small letter. And then when you're using a small letter, make sure you underline that small letter because you're dealing with vectors. And then last but not the least, also for the sake of the syllabus and also what comes in your final exams in mathematics, we talked about how we can represent a vector using vector representation in component form. Now, component form is very cardinal because it has some idea that comes from the graphical knowledge. Okay, so if you know how to plot points on the graph paper, you know how to just read coordinates, okay, like x, y, x comma y, something like that. So I hope you understand what I'm trying to talk about. So that's what is covered in the previous video, an introductory part to vectors. Now, in this second part or version of our topic, we'll look at the magnitude. Now, what is the magnitude? A magnitude is just simply the size of the vector. Okay, so this vector can be a force, a displacement, acceleration, velocity, which have both direction and then as well as the size, how big that thing is. Okay, now we'll look at two parts under magnitude of vector. We'll look at how can you find the magnitude of a vector when you're just given one pair of a point, like in the example or just on the board I've got, for instance, like find the magnitude of the following, like AB as well as CD. So this is just one pair of the point, and then also that is one pair of the point. So how do we find the magnitude to that these are vectors that we're given? So I want you to pay attention and follow me as I go step by step, just to show you how you can calculate the magnitude of something. Okay, now for those who have done maybe coordinate geometry, this can also be referred to as a modulus. Okay, the distance between two given points. Okay, and this is just the same thing that we are doing, just how big the size is from whatever points of consideration that we are looking at. Okay, so now with that said, now we can now see what we have to do now. So now we see that the magnitude of a vector AB. Okay, so when you're using a vector in capital letters, make sure that you underline the vector on top. Okay, so showing that this vector is starting from A and ending at B. So let us make sure we do understand that. So the magnitude, what is a symbol for the magnitude? So when you have a vector such as that, AB is written as you put the parallel lines, and then you put the actual vector in between those two lines, and now this becomes what is known as the magnitude of the vector. And then the magnitude of a vector when you are using a small letter, which we looked at representation of vectors in the introductory part, so make sure you watch that one. So you can have a vector in small letter, which is, we always underline when you're presenting vectors using small letters, okay? So the magnitude of the vector is always just the same. You put the parallel lines and then the actual vector inside, okay? So at the end of the day, what we're just doing is that the vector we are trying to find is just the distance between, for instance, between A and B, okay? So we are just trying to get the distance between A and B, okay? Now, so now let's now move on. Now let us look at an example, okay? This example is saying that find the magnitude of the following vectors, okay? So A, we've got AB as our vector, which is in component form, which is one of the ways in which we can represent vectors, like we saw in the introductory part. So the first number represents, the x movement, or it's a number in the y-axis, okay? The x-axis. And then the second number represents the value in the y-axis, or that is a number we are supposed to put in the y-axis. And then the second example, which is B, we can see that the first number, or the number on top there, okay, the number on top there is -2, and that number is now found on the x negative part of the graph paper, or just the x or y plane. And then the bottom number, that is 3. So we see that we are looking at how can you find the magnitude, okay, of a vector which is just one pair of a point, okay? So these numbers can transition, okay? They can be transformed to coordinates, okay, like x, y, okay? So the number at the bottom is the x number. The number at the top is the x number, and then the number at the bottom is the y number. So once we get that figured in our mind, then now we can begin to just look at what kind of a formula that we are going to use in order for us to find the distance between A and B, which is just the magnitude, or also which is just the modulus between A and B, okay? So now let's see how we can solve, the magnitude of the following vectors in our first example.